This video is about functional group chemistry. The keywords in the question are, it involves CFC compounds, it tells us that it occurs in the initiation step, and it asks us specifically for the function of ultraviolet light. And so the concept of this question is ozone depletion. So for ozone depletion to occur, there needs to be a presence of a free radical. And so the free radical here is chlorine. And so we need to work out an equation where the product is a chlorine free radical. So if we were to go back to the question, it gives us an example of a CFC compound in the diagram, and so we can use that in our equation. So we would get CF2Cl2. And so since we get a free radical, the other element also needs to be a free radical. So if we were to complete this equation, we would get CF2Cl free radical plus Cl free radical. And this happens because if we were to draw out a diagram of this element, we would, and remember, this only occurs when there are present of UV light, and so when it breaks the bond between carbon and chlorine, it splits it homolytically, means each of the electron in the bond goes to each of the element. So we get two free radicals. And the UV light, the presence of UV, is represented above the arrow with the symbol of HV, and that just means the same thing as UV. And this first step right here is called the initiation step, because it initiates a chain reaction where the chlorine free radical will go on and react in several more steps. And so what happens is the chlorine will react with the ozone, and that's O3, to make ClO free radical plus O2. And you can see how ozone is depleted and oxygen is created instead. And then the free radical then goes on to react with oxygen, and this is just free floating oxygen in the atmosphere, to create more oxygen and another chlorine free radical. And we can see how the product actually ends up to be the reactant of the first reaction, and so it occurs in a cycle, and ozone is constantly getting depleted into oxygen. So if we were to go back to the question, we know that it tells us that it occurs in the initiation step. It involves ultraviolet light. So we're looking at the bond between carbon and chlorine. And we know that it will produce a free radical. So this bond is broken down homolytically with the presence of UV light. And with the same thing over here. So the answer to this question is number 3. UV light breaks the carbon chlorine bond in CFC